Software engineering is often described as one of the most attractive careers in the modern economy. High salaries, flexible work environments, and global job opportunities attract millions of people toward the technology industry. But behind this image, there is another reality that many engineers experience after several years in the field: burnout. Across the industry, developers frequently report exhaustion, stress, and loss of motivation, despite working in highly compensated roles. Understanding why burnout appears so frequently requires examining how modern engineering work is structured. Now, salary breakdown. Software engineering compensation can be extremely competitive compared with many other professions. Entry-level engineers in the United States often earn between $80,000 and $110,000 per year. Mid-level engineers frequently earn between $120,000 and $160,000. Senior engineers in major technology companies may earn well above $200,000 in total compensation. These salary levels often create the expectation that the career should feel sustainable and rewarding over long periods. However, compensation alone does not always prevent professional exhaustion. Now, workload structure. Another contributor to burnout in engineering careers is the constant need to keep learning. Technology evolves extremely quickly compared with many other professions. Programming languages change, cloud platforms introduce new tools, and entire development ecosystems can shift within a few years. Engineers often feel pressure to remain technically relevant while also completing their daily work responsibilities. This creates a situation where professional learning does not end after the workday finishes. Developers frequently study new frameworks, tools, or architectural concepts during evenings and weekends in order to remain competitive in the industry. Over long periods, this continuous learning requirement can contribute to fatigue if engineers are unable to balance growth with recovery. Modern software systems are extraordinarily complex. Large platforms often consist of dozens or hundreds of interconnected services running across distributed infrastructure. Engineers responsible for maintaining these systems must understand how changes in one part of the platform affect the rest of the system. This complexity can create constant cognitive pressure as developers manage large code bases, production incidents, and ongoing feature development simultaneously. Over time, this continuous mental load can contribute to burnout. Now, operational pressure. Another source of stress appears when engineers become responsible for production systems that must operate continuously. When services fail or infrastructure becomes unstable, engineers may be called upon to diagnose and resolve problems quickly. Incidents that affect large numbers of users can create intense pressure for engineering teams. While modern monitoring and automation tools reduce some of this burden, operational responsibility remains a core part of many engineering roles. Now, industry expectations. Another element influencing burnout is the visibility of engineering work. In many technology companies, the performance of software systems is measured continuously. Metrics, monitoring dashboards, and operational alerts provide constant feedback about how systems are behaving. While these tools improve reliability, they can also create the sense that engineers are always responsible for maintaining perfect system performance. When outages occur or systems degrade unexpectedly, developers may feel personally responsible for resolving the issue quickly. Over time, this constant operational awareness can create a psychological pressure that many engineers need to learn how to manage. Technology companies often move quickly. New features, product launches, infrastructure migrations, and system upgrades frequently occur under tight timelines. Engineers may feel constant pressure to deliver solutions rapidly while maintaining reliability and security. This pace of development can make it difficult for developers to maintain sustainable work rhythms over long periods. Now, long-term outlook. Despite these challenges, many engineers maintain long and successful careers in technology. Over time, experienced developers often learn how to manage their workload more effectively. Senior engineers frequently gain greater control over how projects are structured and how technical decisions are made. This increased autonomy can significantly reduce the stress associated with early career engineering roles. Now, positioning strategy. Engineers who manage burnout successfully often focus on building sustainable career habits. Learning how to design reliable systems, improving collaboration with other teams, and developing clear boundaries between work and personal time can help maintain long-term productivity. Many experienced developers also move toward roles where their impact comes from architectural decisions rather than constant implementation work. Now, risk and resilience. Burnout does not mean a technology career is failing. Instead, it often reflects the intense pace at which the software industry evolves. Developers who recognize these pressures early often learn how to adjust their work style and career direction. Organizations are also becoming more aware of the importance of sustainable engineering practices. Now, final verdict. Software engineering remains one of the most powerful careers in the modern economy, but long-term success in the field requires more than technical skill. Engineers who learn how to manage complexity, expectations, and workload often build careers that remain both productive and sustainable for decades.